Welcome to Fall in Love with Geoscience. This is an event in collaboration as a collaboration between IEEE GRSS Bangalore chapter and TIGS. So what we will do today is we will first briefly talk about what IEEE GRSS is, and then we will go about the TIGS. So welcome all. Good morning. We are happy to have you all here. Let me just get started. I'm Professor Jaya Srivalsan Nair. I'm with IIIT Bangalore, and I chair the IEEE GRSS Bangalore section. So we'll just see this video.
GRSS
is the IEEE
Geoscience
and Remote Sensing Society.
Our mission is to build a community of researchers and practitioners by means of knowledge sharing and scientifically rigorous dissemination of the latest advancement in remote sensing.
The technical committees are really meant for doing the technical outreach to other parts of the research community and industry.
We want to inform our members and reach different communities via different channels, like for example social media, journal, and especially education.
At the moment we have more than 60 chapters and 20 student branches all over the world.
I love GS family very much and I'm very honored to be the member of it.
Being part of GRSS allows me to be a better researcher and professional, improving my skills and knowledge to do a good job. Come and be part of this great family. Ciao!
I'll request Gurudatta to take over.
Thank you, madam. Hello all. We just had the video of about IEEE, but I see that some of the people had audio issues. If you see in the chat comment, there is a link posted. Maybe you can go through the link in your free time so that you get a basic idea on what is IEEE GRSS. So GRSS is just an acronym for Geoscience and Remote Sensing Society. Hope all of you are staying safe in this moment of the pandemic. IEEE GRSS Bangalore Section is happy to host today's talk delivered by Dr. Chandra Shekhar Balachandran. It's on the topic of geoscience, and it's been aptly titled as Fall in Love with Geoscience. A quick introduction about Dr. Chandra Shekhar Balachandran. Dr. Chandra Shekhar Balachandran is the founder and director of the Institute of Geographical Studies, TIGS. He has a Ph.D. in geography from Kent State University and has been passionate about geoscience education. Being a geography educator himself, Dr. Balachandran has been actively following his passion through his institute, TIGS. He has written numerous articles in leading newspapers of India about how geography plays a crucial role in day-to-day life. He has published a book, Geography Everywhere, and it encompasses various aspects of geography in everyday life. It is a page turner. I would say, sir, you should share the link about your book so that most of the people can access it and read through it and benefit from what the inputs you have made there. Before proceeding towards the event, a bit of a housekeeping. Please mute all your mics. If you have any questions, please type them in the Q&A window or the chat window. They will be answered at the end of the session. If you want to talk to the presenter directly, then raise your hand using the tool at the bottom of your screen, and the moderator will unmute you and you can ask your question. Thank you, Dr. Balachandran, for being with us today. Over to you, sir.
Thank you very much. It's a pleasure to be here with all of you, and I'm hoping all of you are able to hear me clearly. Mr. Gurudatta said that I've been involved in geography education for some time now. The main inspiration for me to become a geographer and to have this passion for geography, there are two reasons. My teachers, these two teachers of mine, on the left is my high school geography teacher, and on the right is my PhD guide. These are the two heroes who really inspired me to become a geographer, and I'm now following their footsteps. Okay, this is just a little bit of an addendum to what Mr. Gurudatta said. I'm a native of Bangalore, studied in the US and all that, and I returned to India in 2000. And I've been continuing to work in geography education even after my return here. It was one of the reasons for my returning. And uh, established the Institute of Geographical Studies. And through this, I've been carrying out a lot of activities. So I keep telling anybody who will listen that I eat, drink, breathe, think geography. I live geography. So whatever I say today comes from that point of view of uh, being an ardent student of geography. So let's go to the next slide. Let's get started. Let's go to the next slide. So when we talk about geography, what is happening in India generally is uh, we teach geography, the subject, not geography, the discipline. When we teach geography, the subject, we are simply passive consumers of geography information, not even knowledge really, just so that we can write answers in an exam and get marks. We do not see geography as a presence in our lives, that it is integral to our life. So, to understand geography as a discipline, what we need to do is to look at the questions that geographers ask. The first question that a geographer asks is of location. Where is something? Where is it? So once we understand the location of where something is, we can draw many inferences from that kind of understanding. When we get to understand where different things are, we can understand the nature of the distribution of those things. For example, uh, residences. Where is a residence? When you get the information for a cluster of residences, then you know if there is a pattern to that. How densely are they packed? How are they distributed? Are they all to one side of a road or the other side of a road? Are they evenly distributed? These kinds of questions. And we will see how these kinds of questions can help us in due course in the presentation today. So having understood where something is, the second question that geographers ask is why is it there? So to understand why something is there, we look into history. So suddenly we are going from geography into history. I'll come to these disciplinary boundaries also in just a short while. So the second question is to understand why something is there. So today we say uh, India has the highest number of COVID cases, COVID positive cases. That is what, where is the highest number of COVID cases? In India. Why is it in India? That is the question. That's the kind of questioning a geographer takes from the first of location to why it is there. And we can understand this by looking at a variety of factors and processes that are involved. Okay, let's go to the next question. In the third question, the geographers ask, so what? So what meaning? Yes, this is where it is. Yes, this is why it is there. But what is the consequence of it being there? What is the consequence of India having the highest number of COVID cases at present? So those consequences we can understand when we start looking at how India is connected to the rest of the world, how places within India are connected to each other. And a lot of all of this is geography, understanding of geography. Let's go to the next question. The fourth and final question that a geographer asks is what if? What if uh, we look at all of these COVID cases in India, it's a very high number. What if we isolate people in a more rational way? What if we make certain changes to providing oxygen? For example, in Bengaluru, there was this news item I saw a couple of days ago where all oxygen carrying vehicles will be able to go through a signal-free corridor. They'll be provided priority access on the roads. So what if we do that? Can we get oxygen more quickly to people uh, who are in need of oxygen in the hospitals? So those kinds of questions are what geographers ask. So the example I gave you so far has been COVID, but the pandemic involves not just a pathogen, not just a disease that is going from person to person, a virus that's going from person to person. It involves a lot of other things: ecology, economics, politics, international relations, and of course, at the center of all of this is geography. So now, if that it that we are looking at is a natural science phenomenon, such as the migration of birds, such as the uh, earthquakes. There was one in Assam recently, just a few days ago. So, well, if that is natural science, and you look at that natural science in connection with geography, then you're looking at geoscience. So, all of this to lead to the definition of what is geoscience. So, understanding natural sciences in the geographical context, particularly looking at physical geography and natural science combination, that is what we call geoscience. Now, I'm using terms such as geography, natural science, physical geography, and so on. These are all disciplines that we have created for our convenience. Life doesn't work clearly along disciplinary boundaries. Our life is not, we do not have a geography life as opposed to a history life, as opposed to a chemistry life. It is not separate. So it's very important to keep in mind that whatever names we give to different phenomena, they are only matter of convenience for us. Let's go to the next slide. Next, so let me give you some examples. So here are two examples. I'll give you two more after these two. If you look at the climatic patterns, look at the climatic patterns uh, around the world. Some places are cold, some places are hot throughout the year. Some places have alternating cold and hot, some places are dry, some places are wet at different times for different durations. To understand this, we have to understand physics, we have to understand chemistry, we have to understand biology, we have to understand mathematics and geography. Geography ties it all together. Likewise, when we look at patterns of agriculture, for example, we have to understand physics, chemistry, mathematics, natural sciences, as always. But in addition, we also have to understand social sciences such as anthropology, economics, and geography. Okay. Two more examples of that. Can you please click to those? The third example is, as I mentioned earlier, the example of COVID. To understand which, we need to bring a lot of disciplines together: epidemiology, biology, ecology, physics, chemistry, mathematics, the social sciences such as sociology, anthropology, and political science. But all of them come together, and we can understand those interconnections when we are looking at this from the point of view of geography, because everything is happening in geographic space. And finally, we look at a lot of the conflicts in the world today, a lot of political, uh, alliances that are made and alliances that are broken depend on fossil fuels and where they are located. Again, look at how everything has to come together, and geography brings them all together. To get that holistic understanding, geography is very essential. So I'm going to revert now to geoscience, uh, looking at geography and geoscience and how they are connected using a very, very broad example. Can we go to the next slide, please? I'm going to look at the first. So let's start with the various spheres that we kind of read in the passing in geography class. The important structure of this and the importance of Earth as a system is never brought out in our textbooks. So let's take a very brief look at this and understand how these systems work and where geoscience as a study fits in. Okay, so let's begin with the atmosphere. What does the atmosphere contain? It consists of various gases. It's a sea of gases plus dust plus microbes. So that whole thing, we are all living in it. Without it, we cannot survive. We breathe. And it's breathing that gives us life. It's breathing that also can bring us death, as in the case of microbes in the atmosphere that we may breathe and catch infections. Next is what we call the hydrosphere. This is the water component of the Earth system. So in this, we include everything that has to do with water: lakes, rivers, seas, oceans, glaciers, so on and so forth. But even here, we find a lot of what is found in the atmosphere is also found in the hydrosphere. Dissolved oxygen, dissolved concentration of dissolved carbon dioxide rather, and dust and microbes, all sorts of things we find in the water sphere as well. The third is the lithosphere. Litho means rock. So this is the part of Earth that we refer to with rocks and soils. These are vibrant entities, and without them, life cannot exist. In fact, you will see that all the three spheres intersect, and that is where we find, can we go to the next one? That's where we find the biosphere, because that's the living sphere of life, for which we need soils, we need the atmosphere, and we need the hydrosphere, right? So the first point to understand is that all of these spheres, next, let's go to the next. First point to understand is that they're all interconnected. All of them are interconnected. All of them are interconnected, which means things from the lithosphere are moving into the atmosphere and vice versa. From the atmosphere to the hydrosphere and back. From the lithosphere and to the hydrosphere and back. These are all circulating, constantly circulating. So for example, when we have rainfall, we have something from the atmosphere coming to the hydrosphere. When we have rainfall over land, we're having something from the atmosphere coming to the lithosphere, from there flowing into the hydrosphere. They're all interconnected, which means, next, which means any change that we make in any one of these will affect all of them. So we cannot say what my actions in the lithosphere on land do not have any impact on the water sphere or the atmosphere. It does, they do, which is how come we find ourselves where we are today, right? Okay. So then the common question I get is, and I used to have this question too when I was in high school, well, yeah, this is all fine, but where am I? I'll never use these things in my life. We may not use it, but we need to at least understand what is going on. For example, I'm going to show you in the next slide a short video, a live feed of what is going on right this minute in real time in Iceland. Shall we go to the next one, please? Yeah, let's play that. While that video is playing, this is a live feed on YouTube from a current volcano that is actually erupting in Iceland. Volcano is erupting in Iceland. So what does it have to do with me? Well, the gases that it gives out go into the atmosphere. The atmosphere circulates a lot, so we will eventually end up having those gases as part of our bodies, literally. The lava that flows out of a volcano, as it flows out and cools, it is forming new rock called basalt. That rock is full of all manner of nutrients for life. So when that rock erodes and becomes soil, volcanic soil, that soil is extremely fertile, which supports a lot of agriculture. That is one set of things to look at. Also, where do we choose to live? Where we choose to live depends on not just the fact that there may be water there, but what kind of soil, what kind of climate. Are we living close to anything that is very dangerous, such as this volcano? So these are all things that affect our lives. And volcanic actions occur throughout the world, in so many parts of the world. So those volcanic actions have impact on human life. Can we go to the next video, please? In the next video I'm sharing, it's going to talk about as you watch the volcanic ash erupting, please also note the vegetation that's in the foreground of the video. Okay. All right, we can stop that video and move on to the next slide. So the point of showing you these volcanic eruptions is that they have impact what is going on under Earth, under the Earth, and what is coming out from Earth has a lot of impact on our lives, on all life, in fact, right? So, but to understand what is going on with Earth, where do volcanoes occur? Why do they occur there? What are the things that come out of a volcano? When might a volcano erupt? These are all things that are based in understanding natural science, geology, chemistry, physics, mathematics, you name it. But we are also looking at the location of these things. That's where geography brings everything together. Where does this volcano occur? Where is it? Why is this volcano occurring there? Why is it there? So the volcano is there and it's erupting. What are the consequences? So what if? If the volcano is there and it's going to erupt, or it is erupting already, what if we get all the people out of there? So when Sinabung erupted a few days ago, the immediate orders given out by the Indonesian government was to ask people to move at least 3 kilometers away from the mountain for safety. Yeah? So what if we what if we evacuate all the people a further distance? That has a lot of implications. But at the same time, the volcanic ash that is being deposited on the land there makes the soil fertile, which is why the tropical climate plus the richness of the soil make Indonesia's land very, very fertile, agriculturally rich, which means a lot of people are living there, making a livelihood using agriculture, through agriculture. But to understand this, we cannot simply say, I'm not interested in chemistry, I'm not interested in mathematics, I'm not interested in geography. It doesn't work that way. We have to look at everything together to understand. So I'm working towards why you should care, why we should care about knowing all of these things. Now we looked at the lithosphere. Let's take a look at the atmosphere. This is a live connection to a site called ventusky.com, where you can go and you can adjust various views and look at how the atmosphere is behaving at that moment. Is real time. So you can look at anywhere in the world and see where the pressures are low, where the pressures are high. Understanding physics tells us that air always flows from high pressure areas to low pressure areas, which then tells us which directions the winds are moving in. Once we know that, then we can understand what the impact of it is. Again, we come to the 4 questions of geography, right? So if you want to locate areas which are prone to certain kinds of weather conditions, these kinds of tools help us. But how is this map being shown to us in real time? Physics, chemistry, computer science, satellite technology, all of these combined with geography is how we are able to see this on a map. So this has a lot of use for us to understand how the atmosphere works. So I looked at the atmosphere and the lithosphere. Let's take a very quick look at the oceans. This has audio. Please listen to it carefully. It's a very short video.
Ocean circulation plays a key role in distributing solar energy and maintaining climate by moving heat from Earth's equator to the poles. At the ocean surface, currents are primarily driven by winds. Deep below the surface, however, currents are controlled by water density, which depends on the temperature and salinity of the water. In a few important regions, such as the North Atlantic, seawater can get cold and salty enough to sink to great depths. This globally interconnected process of overturning circulation occurs in all ocean basins and helps to regulate Earth's climate. Aquarius will measure the salinity in the ocean, giving scientists the tools needed to improve predictions of future climate trends and events like El Nino. Until now, researchers did not have a full set of data on ocean salinity and how it impacts climate change. Aquarius salinity data, combined with data from other sensors that measure sea level, rainfall, temperature, ocean color, and winds, will give us a much clearer picture of how the ocean works. Will higher temperatures intensify evaporation and alter sea surface salinity patterns? Will changes in salinity affect ocean circulation and how heat is distributed over the globe? The GRSS's measurements will provide a new perspective on the ocean, how it is linked to climate, and how it will respond to climate change.
That was a very, very brief look at the hydrosphere and how the hydrosphere movements in the ocean, for example, how they are important and why we should be careful about it. Understanding that, we also should be able to say what actions are might. For example, plastic pollution in the oceans is very high. And a lot of it comes from our individual actions of where we are throwing plastic away. Eventually, it all ends up in the ocean. Next, I want you to look at this uh, collection of pictures uh, and wonder what kind of connections we might make with geoscience, geography, and history among these collection of pictures. You will see, I'll go from the top left uh, corner. You see a picture of beans, irregular beans. Then capsicum. Then we have cinnamon, nutmeg, and cloves. Then we have the word veranda. Then we have the concept, the entity called water. We have guavas, papaya, horses, a statue of Vasco da Gama, precious stones. Then these entities called air and wind. And we have a picture in the center, which is very important, deliberately placed in the center. That's the picture of pepper. We have a map showing the extent of the Vijayanagar Empire at its peak. And then we have a picture of red chilies. If you look at the connections among these things, suddenly you will find that the next time you eat a meal, you will start wondering where different ingredients of your meal originated before they came to India. Yeah. So all of the among these, the chilies, the beans, the capsicum, the guava, and the papaya are not of Indian origin. They came to India from elsewhere. The pepper is very much Indian. So is the cinnamon, nutmeg, and cloves. They're all of Indian origin. So what connects all of them? The hydrosphere, the lithosphere, and the atmosphere connect all of them. We read in our history books that Columbus discovered America. Columbus did nothing of the kind. He did not discover America. However, Columbus set out to find a route to India because there was a lot of demand for pepper in Western Europe at the time. And along with the cinnamon, cloves, and nutmeg, and so on. But they were all going on a land route, the so-called Silk Route. On land, you can only carry so much because you're going through mountains and so forth. The kind of animals that can go through those areas can only carry limited loads. The demand was very high. So the royal houses of Western Europe wanted to find a direct sea route to India so that they could carry a lot more of these things with them. So Christopher Columbus set out trying to find such a land route to India. He did not find a land route to India, but he made another important discovery. Many of the islands he found there and all that, he made very important discovery, and that is, you will see there on the upper left of the map, that is the northwest part of the map, you will see a blue arrows, set of blue arrows showing a circle. That is the wind pattern over the Atlantic. So he discovered that if you catch that wind, you can go all the way towards the what we now call the Americas, and you can actually follow those winds and come back to Portugal. That was a very important discovery, that circular route, which meant while he was still looking for this route to India, wherever he went, whichever island he stopped in, he kept calling it India, and kept calling the people living there as Indians. They said, "Are you mad? We are not Indians, get lost." But while he was there, while his whole group, his large group of people, they found that they interacted with the locals. They found these various things that the locals were eating. Among them were beans, capsicum, papaya, guava, chilies especially. So they collected seeds and saplings and so forth to bring back with them, which they did. They brought it back to Spain. From Spain, it spread to Portugal. From Spain, it also went to Spain's colonies elsewhere. All of those movements were possible because better and better understanding of how winds were moving, what currents were flowing in the ocean, where different land pieces were. Vasco da Gama set out saying that I'll find the route to India, but I won't go the same way that Columbus did. So he takes the wind that goes to the south between Africa and South America. Along the way, he touches outliers of South America, finds a lot of other things that he is never seen before. A lot of those things he carries with him, goes around the southern tip of Africa, catches the monsoon winds, which quickly bring him to the Zamarin of Kozhikode, what the English called Calicut. Kozhikode is the correct Malayalam name for it. He comes to Kozhikode to establish this whole trade thing whereby he can take a lot of pepper back with him and establish trade. But the Kozhikode emperors, the ruler of Kozhikode was not impressed with this. They said, get lost, go away. So Vasco da Gama was really particularly ticked off, personally offended, and he said, I'll come back with guns. And he came back with guns. There was a lot of turmoil and all that. Eventually, he established a colony in Goa, Goa Daman Diu. But interestingly, look what happens. The Vijayanagar Empire, can we go back to the previous slide for a moment? So if you look at the map there, you will see the extent of the Vijayanagar Empire at its peak. And one of the things that made the Vijayanagar Empire so powerful was it had a lot of very precious natural resources under its control, which meant it had a lot of money, which meant they could buy the best war horses they could find. So Vijayanagar Empire was able to buy the best horses coming to us from Central Asia through Arabia through to India, because they could afford it. The neighboring kingdoms could not afford these horses. They got second-rate horses. So once this powerful empire, Vasco da Gama encounters this powerful empire because Kozhikode was part of that empire, the empire could say, no, we're not interested in what is being a go away. That was the power the Vijayanagar Empire had. But then notice what happens. Let's go back to the next slide, please, to the map. So what happens, therefore, is when the Portuguese establish a colony in Goa, the Portuguese who have entered Goa interact with the local people. So they interact with the local people and they start planting their potatoes, their capsicum, whatever there, and they start growing it. And the simple thing, the neighbor says, what is the plant? And they tell them that. This is how ideas spread. Those ideas could spread because some human beings decided to harness the power of winds. Some human beings decided to harness the power of the soil. Some human beings decided to harness the power of climate. All of these come together and suddenly we have in India fruits and vegetables that India did not know about before. Tomatoes, many of the beans that we eat, papaya, sitafala, ramafala, all of these are from South America. So geoscience is embedded in the food that you eat every single day. Every single meal that you eat, you are eating geoscience, you're eating geography, history, and so on. That is how intimately it's connected to us. Apart from that, geosciences also help us understand how changes are occurring on Earth. So check out this visualization on Google Earth. Can we play that? There's no audio for this. By the way, I'll share the entire slide set with you. I'll show you where to find it. So even if you are not able to hear some of the audio, you'll be able to hear it clearly there. Keep observing. 1984 onwards, keep seeing what happens to the ice. Okay, let's stop there. So the ice in the Arctic is melting. Arctic is way up there. I'm somewhere here. Why should I care? Of course, we have to care because all that melting of the ice, that water that's coming from there is going into the oceans, which causes sea levels to rise, which causes changes in the sea temperature, which causes the change of the ecosystem within the oceans. And those affect us because our climate is also affected by ocean currents. This one will play just for a few minutes, and then I'll tell you about the documentary and why you should watch it. Let's just play a few minutes. I'll tell you when to start. So this link is to a documentary that is almost 2 hours long, but is simply one of the most beautifully made documentaries I can recommend to you. This documentary will bring together all that you need to understand about how Earth as a system functions and how things are connected. They ask you very provocative questions and then show you the answers. How are these things happening? All from satellite data. And to put a satellite up, you need to understand physics, chemistry, maths, biology, and then to understand what's going on Earth, you also need to understand geography. So geoscience again at work because it shows us, for example, in this documentary, they show us the connection between the Sahara Desert, extremely dry environment, to the Amazon rainforest, extremely wet environment. The Sahara Desert is supporting the existence of the Amazon rainforest. How is that possible? Once you watch this documentary, all those disciplinary boundaries that I mentioned earlier, geography, physics, chemistry, those boundaries will vanish. You will see Earth as a whole. That's what I hope you'll be able to get out of this whole presentation. Lately, there is a very interesting field of geography called geoinformatics, where geography and information science, including data science, including computer modeling, all of these things are coming together. And people are making amazing visualizations of Earth so we can understand Earth better. A lot of these things are available. In fact, IEEE is also working on this. Dr. Jaya is also working on this kind of thing. You can see all of these things because we are now able to understand Earth better. Because we are able to understand Earth better, hopefully we'll also use that understanding to manage our activities on Earth better. Meaning our actions on Earth can be less harmful to Earth so that our lives are more sustainable, hopefully. So here, for example, this image created on a computer using data from various sources, you can see the uh, lay of the land, the topography of the land. I think it's the Tista basin. Yeah, you can see the Tista basin in Sikkim. You can see how the land is sculpted, and you can see where the ups are and the downs are, and therefore you can see which way the water is flowing. In geography, in geomorphology or physical geography, we have a system of stream ordering. The tiniest trickle of water that begins first and flows towards another channel, we call it the first order stream. Two first order streams join to form a second order stream. Once we understand this hierarchy, we will understand how the water flows within that system, and then we can take effective steps to manage it. Again, we come back to those 4 questions. Where is it? Why is it there? So what? What if? So this is the drainage system. This is how the water moves. Because the water moves in this way, these are the places which have great potential for agriculture, great potential for settlement, great potential for flooding. Nature can be very dangerous also to us, right? But notice something else. This is from a purely scientific point of view, but we also use this in metaphorical sense. We also look at the physical geography landscape and draw spiritual lessons from them. I will not get into that right now because that's a whole different sphere of uh, understanding. But I'll show you where you can explore more of that. Can we go to the next slide, please? In the next slide, we will see an animation of the Kosi River of Bihar and how that river, the course of that river fluctuates over a period of time. So just observe. Notice how it fluctuates, the flow of the river. Why is that important? That's important if you're going to live along the river, you should know where it's likely to flood, where it's going to flood. We can know where to practice agriculture, how it affects life. We can understand all that. If we understand this, again, this is geoscience. Yeah. Let's go to the next slide. So here I talk about why should you know about geoscience? I say you, I actually should be saying why should we know? Let's go to the first point. Basically, this knowledge affects all life on Earth. We cannot ignore it. We may be indifferent to it. We may say we won't study it, but it's inevitable to life. So that is very important. Second point, it also offers, particularly for the students in this group, what can I do with this thing? Yeah, I study geography, geoscience, whatever. What can I do with this? Can I get a job? Of course you can. So there are plenty of study, career, and job options. Career is different from a job. Keep that in mind. So for example, you can find careers in petroleum exploration. Now there is a move towards green jobs, eco-friendly, for example, solar energy, wind energy, and so forth. These are all called, the jobs in these areas are called green jobs because they're ecologically friendly. Environmental conservation, combating climate change. These are all things that people are actually becoming more and more passionate about. Young people especially, they want to make a difference because it's their planet. Our generation, we have totally ruined a lot of things. And we are telling you, oh, okay, it's going to be your world. Here, take it. So when you take it, these are all going to be skills that you will need to make sure that there is an actually livable planet for the future. For fair, just, and sustainable social and economic development, because economic development and social development cannot occur separately. They have to occur together. Not only do they have to occur together, they must be fair, they must be just, and they must be sustainable. For all of these kinds of things, there are any number of careers, any number of jobs you can explore, for which a good study of geoscience will really equip you with all the skills and tools you need and the intellectual outlook. Now, I keep telling students this. Many years ago, it was the case was that I have a degree in mechanical engineering. I can go to this company, I'll get a job. That is gone. Now you have to be able to show any potential employer that you need me. If I don't work for you, you are going to lose. That is the skill that you need to take to an employer and say, I'm very good in geoscience. Your company does this. This is how my skills will help your company do better. Right? So next point. To put it very shortly, you become an informed and empowered citizen of the world. You make a difference for the better. But while you're doing that, you also earn a good living, because we need to be able to live as well. And that is a very genuine concern that many people have. So where do I start in the time of COVID? Because I can't go to places, I can't meet people that easily. That I hope to give you some ideas in the next slide. Yeah, so the very first place you can start is at the Institute of Geographical Studies, the website. I've given you the link there, and I will share a little bit more in just a moment here. The next point, you can go to the Government of India's website, Bhuvan, where you find a lot of information about geoscience and geography and all of these things pertaining to India. Third point is you can go to Google Earth. Google Earth is a very good, most of these things, you just go there and start playing with them. You learn them as you go along. You don't need somebody to sit you down and give you a lecture on it. Most of the time, all the basics you can master very easily. I did too. Okay. The next point, You can download this entire slideshow from the link I've given you there. I think in all of this, the only thing you need to note down is that link, www.tigs.in/resources. Just note that one link down, go to that link, and you will find at the very top, you will find this entire slideshow presented there with all the video and everything. Okay. So the final point on this slide, I just want to wish you all the best in your explorations. And I believe we have a little bit of time that we can perhaps I can perhaps try to answer some questions. Yeah. So that's one of my favorite views of Earth from 1 million miles, kilometers, 1 million miles away, or is it kilometers? Kilometers away, I think. Beautiful picture. And the quote there is from Chandra Shekhar Saraswati, who in one of his songs said, Mother Earth is your wish fulfilling Kamadhenu, meaning you should care for her. So I always use this quote with this picture. So with that, I conclude my part of the presentation. If there are any specific questions that anybody wants to ask, please please let the moderator know, and we'll try to answer your questions.
Dr. Balachandran, thank you for a very nice presentation, giving a bird's eye view on the various aspects of geosciences. There are a couple of questions here. The earlier question you have already answered. One of the participants had asked if slides will be shared. So you have mentioned, and we have also put a link in the chat window.
Somebody has asked for a link to the book, and I'm going to present that in just a moment. I'll just paste it in the chat room. Just give me a moment while I access it.
Yeah, and while you're accessing it, I just want to tell the participants of this seminar one basic thing. It's like any two strangers who meet for the very first time. The first couple of exchanges is geoscience enabled. We always try to ask where you are from. So if you have seen the presentation of Sir in the very beginning, there is this first question, where is it? So what we are trying to do here is we are trying to familiarize with the other person. Where is this person from? Let us say if we meet someone who is from Bangalore, somewhere outside India. So we first ask, where are you from? Then they'll say India. Okay, where in India? They'll say, I'm in the state of Karnataka, in the city of Bangalore. So the moment someone says, I am from Karnataka, or I am from Maharashtra, or I am from Madhya Pradesh, or Kerala, or Tamil Nadu, eventually we ending up asking them, do you know the local language there? And we try to converse in the local language. So a lot of geography involved in trying to familiarize ourselves with new people across the globe.
Thank you. In fact, I am now very close to finishing a second book, which is very geoscience oriented, which is about climate in India. So I'm hoping it will be published sometime later in the year, probably in July, August, somewhere in that time. So when that is published, that will also be a resource that can be used for teaching.
Sir, there is one question in the Q&A window. Ojasvi Prabha is asking, can you please talk a bit about Western Ghats of India?
That's a very broad request, sir. What exactly about the Western Ghats would you like to know? If there are specific questions, I can answer them.
Ojasvi Prabha, if you can raise your hand and maybe you want to talk, the moderator will unmute you and you can ask your question directly.
So Ojasvi has asked about the origin of Western Ghats. Ojasvi is interested in the
origin of the Western Ghats. Too much for me to be able to go into quickly here. It's too broad a question for me to get into here. So we don't have that much time right now. So let's see if there are very specific questions, more specific.
Okay, Ojasvi, I will share the email address of Dr. Chandra Shekhar in the here. And
sure, I can also put it up. I'll put it there myself.
Sure, go ahead.
One more thing I want to add to all the participants here is just recently we saw NASA landed a mission on Mars, and I think a week ago there was this first unmanned flight on the Mars terrain.
Correct.
Quite a bit of technology that was used to enable this unmanned flight in the Mars area. It makes use of a lot of technologies that is aiding in geosciences activity in Earth. For example, the helicopter which flew, it was fitted with a LiDAR sensor. So LiDAR is a very interesting topic that comes under the geosciences domain, and it is something, a subject altogether. I would just say all of you please Google about what is LiDAR, and also try to look through the links which talks about how the helicopter flew over Mars and all these things. So today what we are seeing is geoscience, we are not just using to study the phenomena happening on Earth, we are also trying to use this experience and implement it across planetary studies.
Excellent.
So there are a
Fantastic
couple of
addition. Thanks,
questions on
Gurudatta.
Q&A. Shreyas has asked, why do geologists keep asking what's in the center of the earth when we all know that it's the core? So I guess, what are they looking for in the center of the earth if they know?
There's always more to know. We can't say we know what we already know everything that's there. We don't know everything that's there. We keep still asking because we need to know more details. There is no end to that knowledge, basically. So we have to keep on asking finer and finer and finer details. Somewhere something, pardon the expression, something earth-shaking might come out from our exploration. So yes, there's that's the beauty of science. Science never says we have understood everything. Even what we understand and we say we understand is still open to revision. That's the beauty of science. And as long as we hold to that, there will always be questions. We can never say, this is it, we have figured it out, it's over. So never. So therefore, there's a lot of exciting exploration that our young minds today can go into doing.
So Dia has asked a question on what are some of the jobs that include geology.
Geology. As the ones I listed earlier are good examples of those. Petroleum exploration, for example, any kind of water management issue study, any number of things. Agriculture requires geology, even civil engineering requires understanding of geology. So there are any number of jobs that you can look at. Ultimately, there is no job that says this job is for a geologist. That kind of thing is gone. Now you have to say, this is the job you have. You need a geologist for that, and I am the person to do it for you. That confidence and that competence is what children who are now studying in schools should grow into, so that they should make the employers say, my goodness, if I don't hire this person, I'm going to lose. Quick, come on, join us. That is where we are now. So the answer to the question is, geology is your imagination is the only limit. Once you know where all you can apply geology, you apply it there and you show that it can be done. So who would have thought that by eating breakfast, I had breakfast this morning consisting of upama with potatoes and capsicum and things like that. Every time I eat that, I understand my connection with the rest of the world and its history. And I'm able to share that with other children. For me, that is the job. I did not, nobody said, for you to be able to teach geography, you should know this and that. No, I tell them that this is the way of geography teaching that I do. If you don't take that, you're the loser. It sounds arrogant, but that's the way it comes about. So I know geology, I'm good in geology. This is what you're looking for. You're looking for somebody who can do X, Y, or Z. For that X, Y, or Z, you need somebody with good geology skills. I have those skills, therefore you must hire me. That is something that the candidate has to convince the potential employer.
Actually, Dia is very specific. Is there a stream of geology that deals directly with global warming?
I'm sorry, stream of geology?
That deals with global warming.
Again, it's there's no particular stream of anything that deals with global warming. You can look at economics and it deals with global warming. Uh, with geology, I would say look at Earth, plate tectonics, anything. But the thing is, you may study volcanism, but if you have to make the connection between volcanism and global warming. If you study earthquakes, you have to make the connection between earthquakes and volcanism. So a pre-made stream may or may not exist. As far as I know, in India, there is no geology department particularly that's offering any of this. So you will have to make that connection. And that's quite a challenge in India because you are not given the freedom to explore your own directions that you want to explore. You're confined to what the college is able to offer, what the faculty in the college are able to offer. Which is why I think you should start looking at associating yourselves with organizations such as IEEE, the Geological Society, so on. So there's so many people who can help you with that. But don't stick only to the college and say, will the college offer me this stream? That is not a good exploration possibility. Colleges don't offer that kind of flexibility. There are certain papers you have to answer that they're all exam oriented. Go outside the college also. Go talk to your teachers. If you have a good teacher who's teaching you like, talk to them. Talk to them and say, can you help me develop these ideas into where it connects with global warming? So that amount of effort you'll have to put in. There is no pre-made, prefabricated stream, really. To organize
So
workshops in geography.
Gagana Nandini has a good question about if organic farming is related to geology.
Everything is related to geology, everything is related to geography, everything is related to mathematics. There is no question about that. The question is,
I guess you.
are we looking at the part of it and saying, for agriculture, what that was about agriculture, was it? What was the question about geology?
Organic farming.
Organic farming.
Organic farming. Organic farming is a subset of agriculture. Of course it does. If you have to understand the soil characteristics, you need to understand the geology and geography. The soil characteristics, the water characteristics of a place, the climate, the directions of the winds make a huge difference, because if you may be practicing organic farming, if your neighbor is not, and if your neighbor is spraying inorganic fertilizers, pesticides and so on, the wind could carry them to your farm also. You're no longer organic at that point. So yes, of course it's correct. There's a question here from Smita Nair, Miss Smita Nair. Let me just quickly answer that on screen.
Sure. So there's a question from Ojasvi on if there is any study along with the Indian government on assessing the rate of deforestation in India and its effects.
I think so. I think there are, but I'm not particularly, I'm not able to clearly give you a link and say, go check this out. There are studies like that. Perhaps going to Google Earth, what's it called? We just saw that, animations. And I've seen recently, there are people on Twitter. If you have access to Twitter, there are people on Twitter, Indian data scientists who are doing very good work in mapping the kinds of deforestation that is happening in India. Yeah. So yes, there are studies. I just personally don't have immediate access to where to find them. But yes, there are studies. I've seen them. Any other questions?
So I just want to add about that Professor Madhav Gadgil from IISc, he's retired from IISc, but he writes a lot about deforestation in Western Ghats and all of that. So if any of you are interested, you could actually check those things.
He's one of our most eminent, ecologists, brilliant ecologist.
I have just shared a YouTube link. This is for the IEEE GRSS Bangalore section. We also do a talk series known as Bhumandal Talk Series. And some of the earlier talks, maybe people, the participants, you can refer to it, because there are people like Dr. Ramchandra from IISc, and he has touched upon the urbanization aspect and how remote sensing will facilitate these kind of studies. So maybe you all can go through it in your free time and try to gain an overview on how geoscience is actually being used in a lot of these aspects. Another point I would like to tell to everyone is today everybody is a smartphone user. So knowingly or unknowingly, we are all users of geoscience. Dr. Balachandran sir touched upon the topic of geoinformatics when he said it's a mix of geosciences and information science. So if we open our smartphone, we come across, since most of us are Android users, so I'm sticking only to Android, but even iOS also, there is something called a Google Map. And in the Google Map, we are doing all this basic analysis, find out where is this place, how much is the distance to it. So all these things are the applications of geoinformatics. Even to the matter that services like Uber, the taxi hailing services like Uber, Ola, and the food services like Zomato, all these things are a byproduct, or they make use of geoinformatics as one of the solution for their business proposals. In fact, last year when the first wave of COVID outbreak happened, we all used to see on newspapers and on news channels the map with a live update on where all the infections are happening. And there was a big talk about this university, Johns Hopkins University in America, who could give live to the second update on what is the extent of COVID infections. So they were all making use of geoinformatics to provide this kind of a visual display.
Okay. I just saw a question here, which I don't know what happened to it. Yeah, it's answered. Okay. I just saw a question here. Is COVID related to geosciences? Yes, very much so. I've given the answer there. I've just typed the answer. Just check out the blog at the TIGS site, and you'll find one or two essays on this topic and how they're connected.
There is a question on YouTube Live. Which is the best geography journal or magazine based in India?
There's one called Geography and You. There's one called Geography and You that's published from New Delhi. That is a fairly good magazine. It's kind of modeled after the National Geographic. It's rather modeled after even the logo is very similar to National Geographic. So Geography and You is a good magazine. I can't think of any other magazine that is geography oriented in India. That's the one magazine I have seen. There are academic journals, to be sure. There are also, one other source, of course, is the geography blog at the TIGS website. Well, we don't have a magazine or a journal. That is, it has a variety of topics. So that would be a good place to explore also.
Yeah, so I also wanted to mention there's an online magazine called Down to Earth, which is published by the
I've seen that also.
Environmental Sciences Group in New Delhi as well.
Yes.
I think, yeah. So we could check that out as well. I think we are good on time. So thank you so much, Dr. Balachandra. This has been a great experience altogether. This is the first time IEEE GRSS also has connected with high school students, and we think it's a very gratifying experience altogether, because given the situation of COVID and everybody doing online learning and that, I think as a community we should all connect together and talk about the significance of everything that's there on Earth, and Earth observations, geoscience, etc. So, and all of it touches our lives, everyday life,
and the interconnections among all of them.
Yes, exactly. Yeah. So
thank you
so
so much
that,
for the opportunity. I am very happy to have been a part of this process. Let's do more.
Definitely. So we'll have many more sessions like this, and we have a lot more to discuss on. This is like an ongoing conversation, really, right? So, and yeah, so we'll keep this going on. And thank you so much, Dr. Balachandran, for your patience and the knowledge that you have gathered over the years and decided to pass it on to the younger generation. This has been great.
That's my pleasure.
So thank you.
Thank you so much.